44, they want the real and complex solutions of x cubed minus 27. So there are a couple ways to do this. There's going to be one real solution and two complex. And here's why. The graph of x cubed minus 27 basically just looks like the x cubed function, but it's going to be shifted down 27 units. Okay? So will that red curve hit the x-axis once? Yes, okay? And it should happen when x equals 3. The reason I know that is 3 cubed minus 27 is 0. So x equals 3 is definitely the real solution. All right? You can find the complex solutions two different ways. You can either, method 1, use the root we just found and do synthetic division with 1x cubed, 0x squared, 0x minus 27 to try to see what this factors to. This is from Unit 3. We know that this factors to x minus 3 times something, but we don't know what that something is. Okay? The reason I know x minus 3 is a factor is because I already know that 3 is one of its roots, right? It was always opposite. If 3 is a root, x minus 3 is a factor. So, as you go through synthetic division, you bring the 1 down, 3, 3, 9, 9, 27 with a remainder of 0. So this helps us find that the other root in that, the other factor in that red blank is 1x squared plus 3x plus 9. That's the other factor right there. The other thing that might ring a bell for you, method 2, was called the difference of cubes. The difference of cubes was when we had a perfect cube, x cubed, minus another perfect cube, 27, which is 3 cubed. So this was part of that SOAP formula. Remember, same, opposite, always positive? The formula went like this. To factor this, what's the cube root of x cubed? X. Minus, what's the cube root of 27? 3. And then in the other parentheses, you do x squared plus 3x plus 9. Remember, the signs were same, opposite, always positive. That's where SOAP came from. Okay, so we've gotten to the point where we factored it. So now what? Well, unless you think you can factor this red quantity, that trinomial, which I doubt you can, you're going to have to go to the quadratic formula. All right? So to find the other two roots, it's going to be the opposite of b over 2a plus or minus the square root of b squared is 9, right? 3 squared is 9, minus 4 times a times c all over 2a. So it's negative 3 over 2 plus or minus the square root of, what's 9 minus 36 in here? 9 minus 36. Negative 25? 9 minus 36, negative 25. Little recap here. Remember, that was called the discriminant, right? The discriminant. Since it's negative, that means our other two solutions are going to involve I. They're going to be complex. That's why we don't see them on the real graph. We only see the solution at x equals 3. The other two have the imaginary unit involved. So you're going to write them like this. Negative 3 over 2 plus or minus. What is the square root of 25? plain 25 is 5. Since it's negative, it's 5I over 2. Those are the other two roots for that function. So the three solutions are x equals 3, and the other two are negative 3 halves plus 5 halves I, and negative 3 halves minus 5 halves I.